F of x equal to x sin x when x is between 0 and pi by 2. When x is less than or equal to pi by 2, and pi by 2 times sin pi plus x when x is between pi by 2 and pi. Right. Now, whether this function is continuous or discontinuous at x equal to 0, pi, etc. Okay. First of all, 0 is not in the domain. Right. The function is defined when greater than 0, and same pi also is not in the domain. Right. So these are not even in the domain. Let us check about pi by 2. Right. So first of all, when a function has to be continuous, what does that mean? F of x has to be continuous at c. That means f of c should be equal to limit x tends to c. F of x. That means the value of the function at c should match along with the limit. So the function should approach c from the left hand side, right hand side. At the same time, the value of the function should also be the same limit. Right. Now x sin x when x equal to pi by 2. F of pi by 2 is what? Pi by 2 is here. So f of pi by 2 is pi by 2 sin pi by 2. Sin pi by 2 is anyway 1. F of pi by 2 is 1. Similarly, at the same time, when you are approaching from the left hand side, it is the limit is also this thing. Limit and value of the function is same. So, right. So, left hand side, we are getting pi by 2. That is pi by 2. If we are approaching from the right hand side, what are we getting? We are getting pi by 2 into sin. Sin pi plus theta is actually equal to minus sin theta. Right. So, minus of sin pi by 2. Right. If I are approaching from the right hand side, which is nothing but minus pi by 2. Right. So, right hand side, if I are approaching, we are getting minus pi by 2. So, both limits are not matching. One side we are getting this, another side, one side we are approaching pi by 2, another side we are approaching minus pi by 2. So, both, and the value of the function is pi by 2. So, we are getting graph something like this. Right. So, it is discontinuous. It is discontinuous at x equal to pi by 2. Okay, so the correct answer is A. It is discontinuous at x equal to pi by 2. It is not continuous, right? It is not continuous because x equal to pi by 2, left side limit, right side limit is not same. It is not continuous at x equal to 0. Why? Because at x equal to 0, f of 0 is not even defined. We need to have both side limits, and the limit should match the value of the function, right? If it is a closed interval, then at least we should have one side limit, that is right hand side limit, if it is a closed interval. Here it is if 0 is an interior point, we need both side limits. If it is an end point, at least we need one side limit. But here it is open interval, f of 0 is not even defined, right? It is not even in the domain, so obviously it is not continuous at x equal to 0. For example, if we talk about root x minus 1 is not even in the domain. So we cannot say root x is continuous at minus 1, right? Root x, the domain is from 0 onwards, right? Root x, the domain is from 0 onwards. So at minus 1, it is definitely not continuous. So here x, the domain is x greater than 0. So 0 is not even in the domain. So we cannot claim it is continuous at x equal to 0. And clearly x is discontinuous at x equal to pi by 2. Now we have to draw this graph. We have to see, look at how these two graphs look like. The first one is x sin x. We know sin x will look something like this, right? X sin x is actually multiplication of this one, but the graph will keep going bigger and bigger, because at this point you are multiplying with 0, at this point you are multiplying with some x which is between 0 and 1, right? X sin x, right? We are multiplying with some x which is always growing. X is always growing, and sin x is growing and falling. So when sin x is 0, obviously whatever x is, it will keep falling to 0, right? When x is, whenever x is pi, then it will pi or multiples of pi, right? It will keep coming back to 0. So for example, the graph will look, I'll show you the graph. The graph will look something like this, right? When it is pi, that is roughly 3.1, it comes to 0. So this is the graph, right? This is the graph we are talking about. When it is pi, it is 0. It is 0. Obviously x sin x. right? When it is 0, 0 into sine 0 is anyway 0, right? And when at pi it is again 0, when at 2 pi it is again 0. Meanwhile, this graph will be multiplied by some number between 3.1 and 6.2. So that's why this curve magnifies. This curve goes bigger and bigger. This is x sine x. What is the other graph? The other graph is pi by 2 sine pi plus x, which is nothing but minus pi by 2 sine x, right? Minus of sine x. How does it look? Sine x is this, right? Minus of sine x is something like this, right? It is just inverted version of sine x. Minus of sine x, right? Now this one is multiplied with pi by 2 times. That means if this is 1, right? If the lowest point is 1, this becomes minus pi. This becomes minus pi by 2. If lowest point is minus 1, it becomes minus pi by 2 because we are multiplying with pi by 2 times. So that's why this graph is like this. And it's the same graph. Same graph, same sine graph, inverted sine graph. It is just stretched. One is stretched to minus pi by 2 and pi by 2. So that is this graph. At this point, what is this point or this point? This is always pi by 2. And this lowest point is always minus pi by 2. Right. So that is this violet graph. This is the graph of minus pi by 2 and sin x. Clearly, we can see, right, one side of the graph at pi by 2. So we are talking about pi by 2, right? At pi by 2, that is some 1.6 or 1.7, something like this. One is positive, another is negative. That's what we had also discussed. Right. At one side we are getting pi by 2, another side we are getting minus pi by 2. That's what we had discussed. Right, guys? Graphically also, we have figured out that the limit doesn't exist, or it is not continuous at x equal to pi by 2. It is discontinuous at x equal to pi by 2.